I think it's good morning here, but I suppose there'll be people who are in different time zones, so it could be good afternoon for other people. Okay, so I'll be chairing this session and during this seminar, and then I will say a few words about Professor Jill Adler, who's known to me for a number of years now. So Jill Adler is a professor of mathematics education in the Wits School of Education. When I say Wits, for those that don't know, it's the University of the Witwatersrand in Johannesburg. And she was the president of the International Commission on Mathematical Instruction in the period 2017 to 2020. She held the SARChI Mathematics Education Chair at the university from 2010 to 2019. Again, that is a chair that is done in conjunction with the NRF, which is the National Research Foundation. Jill has spearheaded several large-scale teacher development projects. The most recent within the chair is called the Wits Math Connect Secondary Project. This work builds on her research on teaching in multilingual classrooms and teacher professional development. Jill is also a visiting professor of mathematics education at the prestigious King's College of London in the UK. She's a recipient of a number of awards, the most significant of which are the 2012 Academy of Science of South Africa Gold Medal, and this was the Gold Medal for Science in the Service of Society. And also she's a recipient of the 2015 ICME. ICME is the International Commission on Mathematical Instruction. So she's the recipient of the ICME Hans Freudenthal Medal in recognition of a major cumulative program of research. I should also just mention that Jill has supervised a number of master's and PhD students in the field of mathematics education. And Jill, it's over to you.
Thanks. Thanks very much, Abdul. Very nice to be on with you and very nice to see familiar faces online. Thank you all for being here. So I do want to start first by thanking the CoE for the invitation. It's very nice to have this opportunity to present our work. And I say our with intent because firstly, the presentation was prepared both by myself and my colleague Craig Punaro, who unfortunately is away and so not able to join today. But when the project ran, and I draw attention to the date, it was while I held the SARChI chair from 2010 to 2019, and it's these 10 years I'll talk about. Craig was the lead of the professional development work. And he took over as interim chair when I stepped down, and he's been central to the development of the project. But also the project is the work of a team. And I do want to acknowledge, I see some of my colleagues from time ago are online, and it's so wonderful to see you. But all the work that I'll talk about today is really the product of teamwork rather than individual work. So I'm going to move straight on into the project and just remind you that it began in 2010. So as I give some of the background in the project, just remember when we're starting, it's over 10 years ago. I will begin with what the problem was as we understood it, what the intervention was that we set up in an attempt to lever change the model that we developed and its practices and processes. And then I'll look at research. There was a lot of research done over 10 years, and I'm going to focus on research related to the impact of the project. And then hopefully, and I'm never very good at this, but hopefully I'll be good enough today to leave time for question and answers. So to the talk, what was the problem? Many of you from South Africa or in South Africa will know we had and continue to have a very poor performance curve. As you can see, this is our senior certificate exam results. This is grade 12. This goes back to the time when we were starting the project. And you can see that the majority of students are indeed failing, with very few scoring high. So as we understood it, it was access for all. Most learners post-apartheid were now in school, but there was only learning for some. And so the big question for the project was, is there a way to shift this curve? Could we push this up a little bit? Could we get people here performing a little bit better, get this down a bit, and also get this up a bit, because we were interested in students being able to get to university and study mathematics. So initially the thought was that we would be working with the whole school, the whole secondary school in grade 12. But we started off and very quickly realized that we needed to pay attention in grade 8 and 9. In the first year, we did diagnostic assessments of basic algebra at grades 8 and 10, and found that the foundations were very poor and indeed unstable. So what I mean by unstable is that the errors were inconsistent. Students made errors and then different errors later on in the test. So showing that there was really very, very poor foundation. And with this, those of you in South Africa will remember we had annual national assessments, the ANAs. The first one when they were grade 9s was in 2012, and the score was shocking. The average was 13%. But from what we'd seen in the schools in our diagnostic testing, we were not surprised. The other important thing, and this relates to the schools that we were working with, is that in addition to poor achievement, we have a very big achievement gap. So we have a range of socioeconomic conditions, and in what we call no-fee schools or low-fee schools, these are schools in low-income communities and servicing children coming from low-income families. And these ANA results were at grade 9, and the TIMSS results, even as late as 2019 in grade 9, show that there's a very big achievement gap between students in these no-fee schools and those students from middle-class areas that are paying fees. So with that, it's important to understand we were going to be working in no-fee and low-fee schools, more about the conditions in those schools. And the first thing for people who are not familiar with the South African curriculum is that it is a very highly prescriptive and regulated curriculum. There's an emphasis on coverage, on getting through the curriculum. And teachers work in difficult conditions in these schools. There are limited resources, material and human. There's limited access to technology, and significantly, learners are not prepared for their grade, by which I mean their learners coming to grade 8 and their basic numeracy is not necessarily in place. Learners in grade 10 have not commanded basic algebra, and so teachers are dealing with these conditions. Also in the lower secondary, which is in grades 8 and 9, we found low levels of teacher knowledge. And one of the reasons for this is that many teachers teaching in those grades are what we would call out of field. And that means they're not trained in mathematics. They didn't necessarily have mathematics in their teacher preparation, or they were not mathematics teachers, but happened to be put on teaching grade 8 or grade 9 because there were teacher shortages or because of timetabling. We also spent time in the first 2 years of the project, and the first year in particular, observing classrooms and teaching, and were not surprised, given some of the results of the diagnostic test, to find that teaching was largely incoherent, by which I mean that it was sometimes, although the lesson was quite clearly mathematics, it was not always clear what the teacher was trying to get the children to learn. So with those, with those as conditions and background, what then was the intervention? What did this lead us to do? And I'm now going to move on to say what we did, why and how, and begin with what we've been able to articulate more recently, but actually was underlying the work at the beginning, was the theory of change we were working with. So our starting point was that we needed to pay attention to teachers, what we call mathematics for teaching. So it's their knowledge of mathematics, but the kind of mathematics that would lead to better teaching. And our assumption and starting point was that if we paid attention to this kind of mathematics for teachers and with teachers, it would ultimately lead to student learning gains. What we mean, for those people that are not in mathematics education, I'll explain a little bit. Mathematics for teaching means that it's mathematics that's specialized for the work of teaching. It's not enough to just know what we would call your subject matter knowledge, your SMK, the knowledge if you've studied any mathematics, that's your subject matter knowledge. But there's also a very important element of teachers' professional knowledge called pedagogic content knowledge. And that's how you turn your subject matter knowledge into being usable for teaching and into being learnable by learners. We're not interested in our project in whether there's a boundary between these and how hard it is. We just knew that we had to deal with both of these, but that we would deal with them separately. So we paid explicit and separate attention to mathematics. When we worked with the teachers, we worked on their mathematics, and separately we worked with them on what it means to teach mathematics in a qualitative way. Our other part of the theory of change was that the professional development that we would do that would focus on maths for teaching would have a direct effect on the teacher's knowledge, but not immediately, and so an indirect effect on their teaching practices. And so we would expect to see some sort of delay in the changes in their practices and in student learning gains. But that was the theory we set off with. And our major intervention is what we call transition maths. It was a year-long course, and we call it transition because it was prepared, it was offered to teachers who were mainly teaching in grade 8 and 9 so that they could improve their mathematics, so that they would be strong enough to teach in grade 10 and help them navigate the transition from grade 9 to grade 10, where we know there's a big dropout in schools or even at the end of grade 10. Our model was a 2-day, 8 by 2 days, so a 16-day course where the teachers came, they left school, they were released from school. It was in one district in Gauteng in the beginning, in the first phase of the project, but not in the second, but they were released from school for 16 days to come to campus to attend the course. 75% of the course was focused on mathematics, and a quarter of it on mathematics teaching. And for that, we had a framework, which I'll tell you about. The mathematics focused on the mathematics they were teaching at school and taking them beyond the levels they were teaching. We focused on algebra, function, geometry, and trigonometry, and you can see mainly on algebra and function. Our teaching focused on getting teachers to appreciate that all lessons are goal-directed. There needs to be a clear goal, and it needs to be a mathematical goal. And this needs to be exemplified with selected tasks, how they're represented, the examples that reflect these, how these were then explained, and how students participated. As you can see, I'm still working down here. The course functioned over a year. There were assignments, there was a selection test, a mid-test, and a final test. And if people are interested in how we got teachers to take the test, we can deal with that in the question and answers. But just to give you the numbers, in phase 1, while we started in 2010, we only introduced the course in 2012, and over the 3 years, 2012 to 2014, we had 45 teachers participating from the 10 schools that we were working with at that time. In phase 2, we wanted to expand the reach of the project. We reached out to more districts, 70 schools, and many more teachers. So now in each cohort, there were over 40 teachers. And what we argue is that the model is lean, with no coaching, there's no classroom-based support, though in the first phase we did do some lesson study. And so it is replicable. It's not cheap because this kind of work of developing knowledge is always long-term and not cheap, but it is lean. The principles behind these, I think, are important to understand, that we were working with mathematics, and I'll explain what I mean by we revisit school mathematics and teach new mathematics. We were working on mathematics teaching with a framework, and we had a particular approach to professional development. And these are important for people and trying to understand how the project worked. So our focus on mathematics was to really present it and be quite explicit about it, that mathematics is a network of connected scientific concepts. It's powerful in its generality, but because of that, it's actually opaque, not easily accessible by learners. And we focused in this way because we saw such poor imitative practices and fragmented and incoherent lessons. And so we wanted to work with teachers on mathematics as a connected network of concepts. For our teaching, as I mentioned briefly, is that we wanted teachers to be clear that they needed to be goal-directed, that all lessons needed to have an object of learning that was focused on, and that they needed to tell a coherent mathematical story. And this was because, as I said before, we found the lessons when we were observing to be incoherent. And for those that have done professional development or have read the field, you'll know that a lot of research has said that it needs to be content focused, i.e. subject focused like mathematics. It needs to occur over time. Teachers need to work with each other in communities. And we also focused on strengthening teachers' current practices towards these, rather than trying to upend their practice and introduce some new and complex pedagogies. We needed to be respectful because they were under such strict curriculum requirements, and also the conditions of and the context of their work. And that's why we worked to strengthen what they were doing so that the mathematics taught would be more coherent. So I'm going to give you an idea, first of all, of what we mean when we say revisit school mathematics. Here is something that you would know is dealt with in grade 9. If you're working in the schools, it's the linear function, and teachers would know this. They would also know these different representations, but what wouldn't be strong in their knowledge is how these connect. That there is a connection between the verbal expression, the algebraic expression, the graphical representation, the input-output relationship, and the table of values. And we work with those and look at the links, but more importantly, help them ask new questions, like where do you see the x-intercept in the table and on the graph? Where do you see the double in the graph? And these new questions are quite challenging for teachers when they start, but it helps them link representations. Here is an example of doing new maths, and I want to make sure that I get all the details of this correct, because this is a very particular example that demonstrates how we approach the mathematics. This maths is new because it's not part of the school curriculum, although teachers might have seen something like this in a pre-calculus course in their initial teacher education. But it's a strategic choice, this function, because it illustrates the concept of domain and range much more clearly than the familiar functions like linear or parabolic or the quadratic function. And you don't have to deal with asymptotes, discontinuities, and so on. So what this does is that it brings the upper and lower bounds of both domain and range clearly into focus. It also helps illustrate this, that the square root of a negative number is undefined in the real number system. That's why the graph stops. And the algebraic form illustrates clearly the vertical and horizontal shifts that come into play, of course, as long as the coefficient of x is plus or minus 1. Also important is the 4 examples illustrate here what we refer to as the importance of variation when you're teaching. The variation in this example set shows what happens as when you keep the expression the same, but actually where the square root is changing, and this is going to change, obviously, the meaning of the function. This helps connect representations, and also we work with the teachers on GeoGebra. It's the software that they can use to draw the graphs, and it's a way of introducing them to technologies, to new technologies. So what then, if those are our approaches to mathematics, what are our approaches to teaching? And I talked about our approaches to teaching being guided by a framework And I'm going to point to my colleague, and she was my postdoc at the time, Elena Rondo, who is online. And hello, Elena, and she's working in the Philippines. And from the Philippines, we still work together, though not as much in the last couple of years. But she worked with me on developing what we call maths discourse in instruction, that framework. And this is the related teaching framework. And it relates to what I was saying before. So we'd work with teachers about the importance of a lesson goal and the mathematics in that goal, what it means to exemplify this mathematics, how you would explain this mathematics and get learners to explain what the mathematics is and how they justify what words they use, and how to involve students in engaging with these and with this mathematics. And importantly, to be able to ask at the end, well, at the end of the lesson, will students know and be able to do what was intended, and how will you know as a teacher? So this guided our teaching work when we concentrated in the 25% of the course on improving teaching. So I'll just give you one example of how we dealt with exemplification, where we used principles of variation. One of the things that we saw, and I think if some of you are not aware of some of the errors that we see lower down in the school, you'd be a little bit horrified, is the difficulties and errors that creep in when learners apply the distributive law inappropriately. And so we work with teachers on what it might mean, and the teachers recognize this is a problem. To get learners to simplify expressions with brackets when the brackets appear in different positions. And this is what we mean. So this is how we would use variation. We would keep one of the expressions invariant, it would stay the same, and then change it, changing the position of the bracket, and be able to ask as we calculate what these are, using the distributive law, what stays the same, what changes, and how might this help us achieve this goal of learners seeing that where the brackets is matters, and where the brackets is a function of using the distributive law flexibly. And that is the generality, is understanding the distributive law and how it is at work at a general level. And so working with variation is quite popular now in the field of maths education, and in working on teaching, in building generality, and in bringing clear objects of learning into focus. So I want to move on now to the other side of the framework, which is what it means to work on explaining mathematics. And again, when we work with this with teachers, we start with a very familiar problem. So for people who've taught algebra in grades 8 and 9, you will know this problem is grade 8 and 9 learners can quite happily say 5p and 4q are unlike terms, and that we can add like terms, we cannot add unlike terms, but then in a test, they will what we call conjoin. They will try to complete this addition and write 9p. So the task we give for teachers is how will you convince a learner that he or she is wrong, and do this in a number of different ways. And we get them to work in their groups and also decide which way of explaining is the most convincing for learners in grade 9. And I want to show you how we then reflect on this. We get the teachers to work it. They put their responses up on posters, and we walk around and we have a look at them. And this is a so sorry, just before I get to that, as I said, this is the teacher task. It's a well-known error in the learning of early algebra. It does disappear. Generally, you'll find this internationally. Many learners conjoin at the beginning of their learning of algebra, but this error should disappear. What we found in our testing, and you still see it, is that in grade 10, it's still there. But we wanted to work with teachers on what are criteria for valued mathematical knowledge, and how do you transmit and communicate appropriate mathematical criteria for an explanation. So this would be the final work with them after we've seen what they've done. And I want to draw your attention to, so what we're trying to do is establish criteria with them and how to attend to explanatory communication. And that what we found in each year when we've done this is the teachers themselves will produce this as an explanation. We can think of 5p as 5 pencils, 4 is just a number. These are unlike terms. So when we add, we won't get pencils. We won't get 9 pencils. These are unlike terms. That will be the explanation that's given. And many times we have wonderful conversations with teachers about why this feels like it works when you treat variables as objects, but it's not appropriate for learning the notion of variable. And so it's more important to develop other explanations. Teachers will argue that this is a useful explanation as it links with everyday life. And so what we try to do is offer them a different way of linking with everyday life, but that holds the integrity of mathematics and that refers to an unknown number rather than an object. Some of the teachers will substitute a number and say it's not valid because if you put 2 in for 5, you don't get 2 in for p, you don't get 9p. And others will give a full explanation, a mathematical explanation that draws on properties that says p is a variable, it stands for any number, and this is not always true. It will be true if p is 1, but that would be the only time that the equation is true. And so that is how we would work with them, with explanatory communication. Okay, and so now I want to, for the next 10 minutes, I've given an introduction to what we did in the project. I want to now turn to the research that we did. And I talk about linked research because the project, especially in the first 5 years, but all 10 years, we were doing research at the same time. When we set off, we did some diagnostic testing, but we hadn't really figured out at that point what would be a good framework for working with the teachers and how are we going to measure impact? How are we going to work this all out? And I'm going to start by looking at our impact studies and what we call the learning gains study. You'll remember earlier I said our assumption was that if we worked with teachers' knowledge and their mathematical knowledge for teaching, this ultimately would impact learner attainment. And so we set about, we started this in 2013, so how are we going to study this? And this kind of impact study is really not trivial. We did a pilot in 2013 of the learning gains study, and why I say it's not trivial is that it's not trivial to connect the learners in a class with teachers who'd been on the course. This is not trivial. So if you're trying to do pre and post tests, teachers shift grades. If you're trying to do it a year after they've been in the course, they're not teaching the same grade, they're not teaching the same learners, there's instability in the schools. And so we needed to find a way to link schools and teachers. We did this, we set up comparison groups. I'm not going to go into detail in this study. There's a lot that's been written about it elsewhere. And I do want to point to my colleague Craig, who's unfortunately not here today. He led the learning gains study. And if he was here, he would be presenting this work now. But what we were able to show, and this was evidence of promise, the teachers taught by the learners taught by teachers who'd been on the course started off lower, improved higher. There was a reasonable effect size, and it showed promise. The sample was small, the scores were low, the gains were small, and so it did nothing more really than say this is promise, and we needed to do a larger study, which we set out to do in the second phase of the project. Because we wanted to link improvement in teachers' knowledge with learning gains, we also needed to find a way to establish gains in teachers' mathematical knowledge. Now, you'll remember when I said we did a selection test and a final test, and you can see here the results and the changes, that these increased by percentage points. These were repeated t-tests, statistically significant. But what is significant here, if you're looking at the gains and saying they're relatively small, is that the selection test couldn't frighten off the teachers. The selection test was a lot easier than the final test. We couldn't give them the kind of test that we wanted to give at the end to see if they'd learned this more mathematics. And so it's substantially more difficult, covers more content. And so the gains here, we think, are underreported. But that said, nevertheless, we could see that across the board, all the teachers, and here's the 125 that had been there in these 3 years, their mathematical knowledge did improve. And I do need to say this was really their content knowledge. We didn't test the maths teaching knowledge in these selection and final tests. So what then about their learners? So if you look at the graphs here, here are the learners of the 2016 teachers. Here are the learners of the 2017 teachers, started off lower, still improved. And here was our comparison group. But I'll give a little bit more detail now. This was a much larger study, as you can see in the number of learners in both years. We worked with teachers who had been on the course but were now teaching either in grade 9 or in grade 10, and did a pre-test at the beginning of the year in February, the end of the year in October, to see if these teachers' students improved. And these were just the teachers who were in the Learning Gains study. And you can see significant gains for the teachers who had been with us in 2016. And remember, this was done in 2018. So it was not only a year after, but it was delayed a further year after they'd completing the course, and their gains are larger than the 2017 teachers and the comparison group. So there is the average change in score. And just to give you an idea, so this is what I referred to earlier as the delayed effect. And the important thing to note here is that we worked with the national department here. The comparison group schools had no contact with the project whatsoever. They didn't know anything about it. The teachers who were in the comparison group knew nothing about the project. And we'd matched the schools as best we could. That's why we call it a comparison group, and we call it quasi-experimental. But what is significant for us is the practical implications of these gains. Although the gains, the performance was still lower than we would have liked, the effect sizes were significant. The effect size of 0.68 is equivalent to about 8 months of additional progress, and here about 6 months of additional progress. And what this means is that the learners of the teachers in the project were having an experience of the equivalent of 8 months more teaching than the comparison groups. And that's significant. And for this work, please refer to my colleague, Craig, he's the expert on this, and it comes from the work of Higgins et al. So those are our quantitative results. And we were very pleased by them, even though the gains were, the performance was still lower than we would have liked. It was to us that the project had accomplished what we had assumed in the beginning, that if we worked on teachers' mathematics, it would impact their students' learning. So what then about teaching? We did a whole range of qualitative studies from the get-go, from 2011, where we were trying to find out more about teaching, and then later to see, well, if we impacted student learning gains, what can we say about the changes in teaching? Could we say anything? How are we to study this? And I'm just going to give you a quick overview of some of the studies that were done. I unfortunately, that's why I say some here, can't refer to all the studies, but this was very important, and I think very important for a Centre of Excellence or people who hold chairs. Your goal is not only, as ours were, to impact practice and to lead an intervention and lead a change, but of course the goal of the chair was also to work with postgraduate students to improve human capacity in postgraduate studies and people moving on into academia. And we were very privileged in the project to have wonderful full-time doctoral fellows working with us and postdoctoral students, postdoctoral fellows. So I'm going to briefly mention some of these studies, and some of the, I think many of our participants in the project are online, our team members, and I'm not going to mention all of you, unfortunately. I'm just going to refer to some as they're relevant to the impact. So here are 3 studies. I've given the publications that have come out with this, because this is also important as a research and development project. Dr. Monowang Leshote is now working at the University of Pretoria, did an early study. I talk about these as some of the early studies on teachers' use of the textbook. She was interested, and we were keen to see teachers had textbooks. Did they use them productively? And the short answer was no to her study, which reinforced, it's a much more sophisticated answer than that, and a more complex answer, but some of it had to do with how teachers viewed and were flexible with their own mathematics. Dr. Vasan Pillay worked with a group of teachers on how to teach using variation. He did what's called a learning study, and was able to show through the study that when a good example set with good variation is enacted in the classroom, it does impact learning. And Vasan works in the province, in the Department of Education. He was seconded to us, and he went back to the department and has remained there, influencing education in that way. And Nsiki Omo, who completed more recently, is now a lecturer in the School of Education at Wits. And why she worked on explanation. What is a mathematical explanation, and what does this look like in mathematics teaching? And you can see here is about example sets and explanatory communication, and so aspects of the framework that we were trying to find out more about in these initial studies. Some of the later studies were done by postdocs who joined us in 2016, 2015, and 2016. And he looked at teacher learning as teacher identity, and published a very nice study on that with 5 teachers. And Jihad Al-Shwaik from Palestine originally, he's now in the USA, undertook some lessons, did a systematic study of our lesson study work. The central work that we were doing, and I mentioned Elena a little bit earlier, was on the framework. We spent a lot of time, and Elena was the postdoc at that time, developing an analytic framework for being able to describe teaching, so that we could look at how at whether we could see differences in teaching over time, and also whether we could use this kind of framework for developing the quality of teaching. I've talked about and mentioned the framework earlier, and in a presentation that I did some time ago, how this operates as a boundary object. We use it for research. We use it in practice to inform our teaching. Elena did further study on the relevance of the framework for looking at textbooks, and she and I have done pre and post video analysis, and she led her analysis of a study where we tried to see where we had evidence of different teachers' levels of subject matter knowledge and videotapes of their teaching. And basically we were able to offer some hypotheses that reflected back into the project that teachers with stronger mathematics for teaching in relation to how they exemplify and how they explain also had stronger subject matter knowledge. And so these related to our underlying assumptions. We had self-reports from the teachers, but self-reports are, that they got better at looking at their examples, how much they've grown. And importantly, given Monowang's research that I talked about around textbooks, is taking their textbooks more seriously, doing the work first, looking for cohesion, so for more coherence. We did a pre and post video study, and I say it's underreported. It was reported in various conference proceedings, so it has been published. But it's not been as easy to get this study into a journal, and there's quite a lot of work in the field about why this work is difficult to publish. We started out with 21 teachers, but only ended with 9 for whom we had pre and post video data. There were significant challenges during the study, unstable context. We only had single lessons, but we were able to analyze these using the framework, and the results were messy, uneven, but nevertheless interesting. And this is why they're difficult to publish, because it's a messy story. We could see expanded example sets, so teachers paying much more attention to varying features. But we did also see, and this is the lag, that it was the teachers whose mathematics strengthened the most who were able to build valid, strong criteria for mathematical, what we called mathematical substantiations in class. So with that, I want to conclude that coming back to our hypothesis and starting assumption, I would hold that we were right to start with focusing on teachers' maths for teaching and focusing quite strongly on their own mathematics. What I've tried to show by linking, talking about the qualitative studies as well as the clear impact study and the learning gain study is that together these add up. They add up to our claim for within the context and within what we were able to do a successful intervention. We did lever up change. Thank you for this opportunity to share with you and look back, and I look forward to questions and answers.
Oh, there we are. It says, can the teaching and learning of mathematics be modeled mathematically and thereby allow us some predictive power of how the system is performing? Oops.
Sure, that's an interesting question from a number of points of view. It's a very mathematician's question. And I don't mean that in any kind of facetious way, but one of the issues of this would be, I'd say it's probably very difficult to be able to do this. Teaching is an extraordinarily cultural activity. It's very bound up with cultural practices. And so establishing a stable model, I would imagine, is not really feasible. There is, however, an attempt internationally through the OECD precisely to try to develop models of teaching. It's very controversial precisely because of the cultural nature of it. And if you're interested in this, please email me and I'll refer you to the OECD work and how they're trying to model teaching and look at it across international contexts. And so provide ways, not just about being able to predict, but being able to work on mathematics education internationally. I hope that's given a satisfactory enough answer.
I think that looks like that is a good answer, because I suppose teaching is an individual thing, learning is an individual thing. So modeling is an attempt to to put things together.
It's very difficult to aggregate this. And the other thing that I've often had discussions with mathematicians about is that the problems of learning are not going to be solved. The issues around learning change as culture changes, as society changes. So it's very difficult to pin this down. What was counted as good learning 20 years ago is not necessarily agreed to as good learning now, because what students need to know is different.
Thank you. Are there any other questions? You could put the questions on the chat or just unmute and direct your questions personally.
I have a question.
Okay, Kevin.
Hi, Kevin.
Thank you. I'll apologize in advance because I had to come and go through your talk, so I might have missed some things, but I don't think it matters because I think it's an important point. You mentioned the cultural aspect right now, and I know in America, and even as far as I know parts of South Africa, there's a lot of emphasis on getting the teachers themselves to interact culturally almost to reinforce their own, to sort of make them feel better about themselves, for want of a better way of putting it. And obviously to also reinforce the things they're learning. I don't know if you did mention that anyway, but I'd be interested in your comments.
I'm not sure what you're getting at directly, but I think possibly what you're talking about is some sort of motivation and identifying with both the practice of teaching, that it's meaningful for you, and that the learning is meaningful for students. So it's how do you make things like algebra meaningful to students? And there is quite a lot of work on what's called culturally responsive teaching. It's not a straightforward phenomenon. So some of that is about linking maths to reality, and so doing a lot more modeling. And there's a lot of curriculum change in many parts of the world to bring modeling more center stage in the maths curriculum. This is not trivial for teachers to enact. But linking mathematics with everyday reality is not always simple, and often is not appropriate, like I showed in that one example that I gave, that sometimes when trying to make it meaningful for students and linking with practices or experiences that they have, don't hold the integrity of mathematics. I mean, unfortunately, some of mathematics is abstract, and one needs to find ways to enable students to get some meaning out of the symbolic system in and of itself. And there are many different strategies for doing that. So I don't know if I've answered well enough that the question is there. There's controversy and debate in the field because the results are not unequivocal of how best to do this.
Yeah, if I could just follow on quickly. Is that all right, Chair?
Yeah, sure.
Yeah, go
No,
on.
I was referring more to self-esteem, that apparently there's a lot of lack of self-esteem amongst teachers. I don't know about mathematics teachers in South Africa, but that's what they found in America. That
Okay, so fine. Okay, so one of the things that I think is really important, and what we were at pains to do in this project, is it's very important to learn from the international field, and we used the research and built on the research internationally and have contributed to it. But the culture of teaching and learning in the US is completely and utterly different from here. Okay, there's also a very different individualistic orientation to teaching and learning in the US in a way that's not necessarily as resonant here. And so while what I'm trying to say is that I wouldn't take necessarily the strategies used in the US. What is important that you're saying from the US is self-esteem. Self-esteem is absolutely critical. So I did refer to one of the studies done by one of the postdocs on teacher identity, and I didn't give the data of that. But what's most important about that was the teachers' participation with us through the course and in support of their work certainly had a significant impact on their motivation. They felt better about themselves, they felt better about teaching, they felt more competent, they saw their students getting better, and that is absolutely critical. So I hope that answers your question.
Yes, thanks.
Okay, thank you, Kevin. Any other questions? I don't see any more questions in the chat. So, CT, you have a question?
Thank you so much. I am so excited with this presentation. It is really clear for me. I think I just want to let you know that your presentation or your work is always with me. And when I visited Shanghai, I accompanied my pre-service students. Your framework really, what I am trying to say, that the application of your framework was really clear when I observed the teaching in Shanghai. All right, the focus is clear, the example is clear, how they explain it, and within 1 hour, they really achieve a lot. And I always said to my student, I've witnessed or I've observed many classes, and that those classes in Shanghai are unforgettable. And every time I remember that class, I remember your framework. It is really helpful for me as a lens to look at the quality of the teaching. But I also want to really say that what I learned from Shanghai, and Shanghai is #1 in mathematics. It's about the preparation of the lessons. So they prepare much longer their lesson than what they enacted. It is really interesting, and I think that's the two things that I would like to say. Thank you so much.
Thank you, Siti. And there's a nice positive comment and angle on your work, Joe.
Thank you. Yes. So I'm going to declare that there's some, Siti was my postdoc in 2012 and 2013. So, but the interesting thing is at that time, the framework wasn't as well developed as she would admit. So it is very nice. And that's interesting that you say about Shanghai. If there's time at the end and people are interested, I'll talk, I can share with people what one of the plenaries at the ICME Congress in Shanghai showed about teaching and mathematics teaching in Shanghai over the last 40 years, which was very interesting to me. And it links into what Siti was saying. So, but I'll come back to that if there's time. But thank you, Siti. Lovely to see you. Thank you for being here with us.
Thank you.
Okay. I see there's a question from Solidad. Please go ahead.
Yes. I would like to know if the participants in your courses come from schools that have fees and non-fees, and if they were together in your courses, or did they have separate classes in your courses?
Okay, thank you. Very clear. I thought I'd made that clear in the beginning. Obviously, it wasn't clear enough. No, we worked only in no fee and low fee schools. So there weren't teachers from fee-paying schools in our courses. That said, we did work with teachers, but not inside the courses themselves, but to strengthen the framework and to do other things in fee-paying schools. We did some of the learning gain study. We did these as well in fee-paying schools so that we would have a contrast. And at the moment, I need to say, we did some presentations and we're working with us on geometry, and Craig is running some sessions for teachers through Wits, weekly seminars, and we have teachers from all schools. And so it is a challenge, and it is interesting when you're dealing with teachers from all the schools because of their different experiences and the different knowledge resources they bring to it.
Okay, thank you.
Thank you, Solidad. Can I just request, Solidad, that you lower your hand? Otherwise, it will appear. Thank you. It will appear that you have another question. Okay. Thank you very much. We still have time for some questions. Bill, you were saying something about, if you had time at the end, you would say something about the conference in Shanghai. Was it something else? Would you just want to explain?
No, I was. So we've just had ICMI, the International Commission of Maths Instruction, where I was president for 4 years. We've just had our 4-yearly international Congress. It was meant to be in 2020 in Shanghai, but it was postponed because of COVID. And we had it in July this year. It was a hybrid conference. It was very successful, interestingly enough, thanks to our Chinese colleagues. And what Siti is referring to is one aspect of that Congress, which was what's called a thematic afternoon. And in that afternoon, our Chinese colleagues showed and shared teaching in Shanghai. As she said, Shanghai is a bit of an outlier in China overall, but Shanghai's results on things like the TIM study and the PISA study are very high. And so there's good performance. But what was fascinating to me was one of the keynote addresses or plenaries was by a very well-known professor in Shanghai who has studied maths education for 45 years, I think it was. And what he's done over time is to track the performance and the teaching practices in Shanghai over this time. And what he showed, which I found was really interesting, and I think that's what Siti's saying is so resonant, is that the first intervention that they did, so when I don't remember exactly when they started the first lot of interventions, but they started off at the kind of extremely low base that I think I was demonstrating in our schools. And their intervention was through principles of variation, as I've discussed, that it is through principles of variation that you can bring key things into focus. And they worked with teachers with principles of variation to strengthen what they called conceptual teaching. And those people that are involved in education now would say it's very important. A lot of our teachers focus on carrying out procedures without meaning. And so they need to be able to work more conceptually. And what he talked about was how long they spent in China building teaching practices through lesson study, through all the interventions that they did, through principles of variation, to build teachers in and their teaching towards more conceptual teaching. And this was extremely successful, and their results improved and improved. What was fascinating to me is in very recent years, they're now trying to move towards more inquiry-based instruction and towards more problem solving. And so it raises the question as to whether you can move straight. So some of the debate in the field is that, and some of what we were doing in terms of strengthening practices is not moving teachers straight off into trying to teach from a problem-solving perspective. This is very complex instruction, but to rather build their conceptual teaching. And it was fascinating to me that this is what was going on in China for many, many years. And now they're moving on to look at how to expand the teaching to include inquiry-based teaching. So I think if anybody's interested in that presentation, it's very, very interesting. It's still available publicly online on the ICME website. So go and have a look if you're interested.
Thank you, Jill. And unless, I think Siti has, I think they will take it as the last question. We're running out of time. So Siti, if you want to go ahead and ask your question, you'll have to unmute, of course.
Yeah, I just want to say one more, Prof. When we analyze the teaching in South Africa, what you always say, it's about the word and the action of teachers do matters. All right, and that's exactly what I observed there. And one interesting thing is also that the teachers, every teacher must have public open class. So during 1 week, I was in that school. I witnessed teachers came and watch and give feedback, and even they also have a modeling where every teacher in the district came into one place, and it's such an amazing practice. Yeah, I just want to say that. Thank you.
Great, thank you. Yeah, we've got a bit of a way to go to have open classrooms, but that is the way to go, and that is why we do lesson study. And I know Elena does a lot of that in the Philippines.
Okay, maybe we should take one last.
Sorry, just hang on. Here's a question from: were the participants, the educators here, chosen because of their schools they were attached to, or because of their competencies? That's a very good question. So in the first, I'll just answer this quickly. In the first phase of the study, we identified schools that we wanted to work with. These were no-fee schools and low-fee schools that were interested in working with the project, and whose head of department of mathematics and principal were supportive of the project, and so supportive of teachers participating. So teachers in the first phase came in via the schools. In the second phase, we worked with the province, with districts, with district officials, and then with schools they recommended, but we reached out to teachers. And teachers were not selected on the basis of their teachers didn't come in, first of all, they came in by choice. So they had to apply to come on the course. And I said we gave a pretest, and the reason we gave a pretest is that first of all, we wanted to identify what it is the teachers were coming in with, so we knew where to start, that we knew what they knew well, we knew what they were comfortable and flexible with, and we knew where there were weaknesses. We also knew from working with the project and working in the first phase that there were some teachers teaching in grade 8 and 9 who knew, and I hate to say this, too little mathematics to come into the project. They gained no traction. In the first 5 years, we had teachers in the project, they did not learn well enough in the course. They made some progress, not enough. Their mathematical base was so weak. And it's shocking to think that they're teaching in grade 8 and 9. Absolutely shocking to think that. And I've said this before, and hopefully there are less and less of those teachers in the schools. But those teachers were, over time, we excluded them from the course because we knew they wouldn't benefit. Since then, we've been working on a different kind of course that would be directed at teachers with lower content knowledge. But we took in teachers in the course whose mathematics was weak, but it was strong enough for us to begin the work with them and not have to start so far back that we couldn't get far enough into the secondary curriculum. I hope that, and it didn't have to do necessarily with their qualification. So many of the teachers, as I said, were out of field. They were all our teachers in schools are qualified teachers. They're not all qualified mathematically. What I mean by that is that they don't necessarily have mathematics in their pre-service teaching. And that's particularly the case of teachers teaching in grade 8 and 9. We had many teachers in our courses who were not trained mathematically in their pre-service training, but had been teaching maths for a while. They came in, some of them were strong enough and they grew tremendously.